Okay, here's another example. So this says 27 math GPAs for MESA students are recorded, and the average was 3.21 with a sample standard deviation of zero point 0.8. So find a 99% confidence interval for the true mean GPA of MESA students, right? So I kind of want to know what the true value or the true mean GPA for all math students are, right? So in this case, I don't know what it is, so I got 27 people. And of the 27, the mean was 3.21 and the standard deviation is zero point 0.8, right? We still want to construct a confidence interval, right? So we know that we have to use one of these formulas. So let me go ahead and pause this really quickly. My phone started ringing crazily. Okay, anyways, but I don't forgot what I was saying, but I said, okay, so we were trying to figure out a 99% confidence interval, right, for the mean GPA, right, for MESA students, math students in this case, okay? So if we look here, which confidence interval do we want? Well, we don't want it for proportions, right, because there's nothing in there that says proportions, but we did look at means, right, so it has to be one of these two. Well, let's go back to the problem. In the problem, it said that we know what the average is, it's just 3.2, and we also are given the sample standard deviation, which is zero point 0.8, right? So if we go back, well, which formula is for the sample? Well, it's the second one. This one is for the one for the sample. So that's the one that we're going to be using. And in order for me to find t, right, I'm going to use a t-table. Okay, if I was given the population, right, then I would be using this z table, right? But since I'm given the sample standard deviation, that's what the problem says, I will be using the t-table. So let me go ahead and write this down. So we know that in order for me to write my confidence interval, right, my lower bound is going to be x bar minus t star n minus 1 s over square root of n. And my upper bound is going to be x bar plus t star n minus 1 s over square root of n. Okay. So let's go ahead and figure out what we got. So we know what our n is, right? N is just 27 people, right? We know what our x bar is, our sample mean, right? Our average in this case, right, was 3.21, a GPA of 3.21. And my sample standard deviation, or S, is 0.8, okay? Now, the only thing that I don't know is our T star, right? Well, remember, our T star depends on what the value of N is, right? So first, let's figure out our degrees of freedom, right? It's N minus 1. So it's going to be 27 minus 1, which gives me 26, right? If you are lost about where this came from, just watch my first video, right, on the t-table. So 26, we want a 26 for a 99% confidence interval. So we are going to go into my t-table. So we want 26, right, with a 99% confidence interval. So 26 is right here. 99% confidence, right? If we go ahead and match them up, we get 2.779. Now be very careful because some of you guys would want to use 27 because in the problem we actually had 27 samples, right? But remember that we subtracted by 1 to find our degrees of freedom. So it's 2.779. Okay, so 2.779. Okay, so that's my T star, n minus 1. The n minus 1 is the degrees of freedom. Okay, so I'm going to go ahead and plug all of this in. So I got 3.21 minus 2.779, okay, times 0.8 over square root of 27, okay. Then I'm going to do the same thing, 3.21 plus 2.779. This looks like a 3, 2.779.8 divided by square root of 27. Okay, whoops, this looks kind of ugly. Let me erase 0.8 over square root of 27. Okay, all right, so let's go ahead and put this into our calculator and see what we get. Okay, so I get 3.21 minus 2.779, and then I'm going to multiply this by the thing in the parentheses, square root of 27. Okay, I'm doing this offline, but okay, so my lower bound GPA is 2.78 and my upper bound GPA, okay, well, let me go ahead and put that and change the minus to a plus, and I will get 3.64. Okay, so my confidence interval is 2.78 to 3.64. So basically, we are 99% confident, right, that the true mean math GPA will land between these two numbers, somewhere in between, right? Okay. All right. So hopefully this makes sense, right? Using whatever the problem gives you. So now hopefully the worksheet will make a little bit more sense.